most of this unit we're going to be concentrating on the connections between magnetism and electricity. And the first one we're going to talk about is a force on a moving charge. It's kind of a strange force. So first we'll note that a charged particle moving in a magnetic field experiences a force. Now, the force it's kind of strange because, first off, the particle must be moving. And the faster it's moving, the greater the force is going to be. So if the particle is just sitting still in the magnetic field, there's not going to be any force. There must be an angle between the motion of the charge and the field. So not only does it have to be moving, it has to be moving at an angle. If it's moving parallel to the field, there would be no force. And the last thing, and we're going to talk about this more later, is that the force is perpendicular to both the motion and the field. The equation to find the force is F equals Q V B and then sine theta. Q being the charge, V being the velocity of the charge. And B the magnetic field. Sine theta is the angle between the velocity of the motion and the magnetic field. So you can see if the velocity is 0, the force is going to be 0. Or if theta is 0, then there's going to be no force. So you have to have an angle in there. So here's our first example. A proton, a neutron, and an electron are moving in an electric field of 2 Tesla. I'll give you the speed here, and I want to now know the force on each. So let's start with the proton. We're going to do F equals QVB sine theta. Now, our angle, it's a right angle, so theta is going to be 90 degrees. Okay, the proton is moving to the right, the magnetic field, the x's mean into the page, so those two things, right and into the page, are perpendicular to one another. So our angle is going to be 90 degrees, and we kind of ignore that sine theta because sine of 90 is 1. We know the charge on the proton is 1.6 times 10 to the minus 19th coulombs. Our velocity is given up above here, is 4 times 10 to the 6th. And our magnetic field is 2. And that's going to give us a value for the force on the proton of 1.28 times 10 to the negative 12th newtons. Now, for the electron, if we think about it, we're going to get the same value because the q is the same, just with a negative sign in front of it. The velocity is the same, and the magnetic field is the same. So our value for that one is going to be the same. So 1.28 times 10 to the minus 12th newtons. And our neutron, what's the charge on a neutron? Well, the charge Q is 0, so I know the force for that is going to be 0. So let's make a note that Q equals 0. Another question I might ask, though, is which is going to have a bigger acceleration, the proton or the electron? And it turns out the electron is going to have a much bigger acceleration, even though the force is the same, because the electron has much less mass. So we have a second example. What is the force on the electron moving in the electric field below? Well, for this one, if you think about it, the force is going to have to be 0, because the electron is moving to the right and the magnetic field is to the right, so theta is 0. So when I do F equals QVB sine theta, the sine of 0 is 0, so that's going to give me 0 for the answer. So whenever they're parallel like this, or if they are anti-parallel, the electron is moving the other way, then it's 180 degrees, and the sine of 180 is also 0. So if they're ever parallel or anti-parallel, you get no force. So just keep that in mind.